Hello and welcome to my channel. I'm Akram and you're watching Knowledge 360. In the previous video, we discussed about bit string data type in PostgreSQL, and in this video, we are going to discuss about text search data type. So, PostgreSQL offers two special data types for full text search. One is tsvector and another is tsquery. So, first, let's start with tsvector. So, tsvector stores normalized lexemes or words from documents. Sorting and deduplication are automatic. If we have a string, a fat cat sat on a mat and ate a fat rat. So here we can see that we have a couple of words that are repeating, but if we pass it to tsvector, deduplication will happen. That means the duplicate lexemes or words will be removed. So let's query this. So here we can see the output. So we have this output and this is passed as tsvector and the duplicate words are removed. Now let's see lexemes with punctuation or spaces. So in that case we need to write like this with this dollar symbol and the eight dollar symbol. Here we cannot write it within the quotation. So this is the complete string, the lexeme, and then the punctuation mark contains spaces. So this is the string. So let's query this and see the result. So here we can see that this is the TS vector generated. Similarly, sentence like this. In this case also we have written like this dollar symbol and at the end also. So within that whatever we have, that's our string. So let's query. This is the way that we store this kind of strings into TS vector. Now let's see lexemes with positions. In PostgreSQL, we can assign each lexemes a position. For example, A is 1, fat is 2, and 3, 4, 5, 6, and so on. So let's query and see the result. So in this case, we can see that it doesn't deduplicate or it doesn't remove the duplicates. Instead, it mentions that this is present how many times and at what position. So for example, A is present at 1, 6, and 10. So we have mentioned A here and A here with 6 and then A here with 10. So this is how we can mention the lexemes with position numbers. Now let's see lexemes with weights, where A is the highest priority and D is the default. So similar to assigning positions, we can assign the weights also. So for example, here we have assigned A is one position and the weight is A and so on. So let's query and see the result. So this is the result and we can see that we have got the lexemes with the position and the weights. Now let's see raw strings are not normalized automatically. So in this case, for example, we have a raw string called the fat rats, but this is not normalized automatically if even if we typecast to TS vector. So let's see the result. So this is the result. But we can normalize this kind of string using the to underscore ts vector function. So here we can see that we have used the to underscore ts vector and we have passed the language, that is English, and the sentence, that the fat rats. So let's query this and see the normalized result. So this is the normalized result where we can see that the word the is not taken into the account. Let's create a table to use this in practice. So here we are creating one table called documents, where we have one column content as text and we have another column content vector as ts vector. So we create this table and insert some data into the table. So this is completed. Now let's see the examples. Here we see the TS query type examples. So TS query allows Boolean logic and search expressions. So in this case, the searching result will be populated on the basis of the words that match or not. So for example, if the search is done like this, fat and rat, that means if both the words are there present, then only we get the result. So this we can, so these are the two lexemes that need to be present in order to get the query result. Similarly, we have this one, fat, and then within the parenthesis rat or cat. So that means within the document we should have a word called fat and either it can be rat or cat. So then we'll get the result. It is like and plus or operator. Then we have another example here, fat and rat and not cat. So that means in the document the word fat should be there, rat should be there, but not cat. So this way we can use the Boolean logic using the TS query. Now let's see phrase search with followed by operator. So in this case we are searching like this in the document. If we say fat is there, it followed by the rat. That means fat and rat should be close to each other. So then only we'll get the result. And there is another example, we can mention the number of lexemes or words. So for example, in the second example, fat will be there, then within two positions rat should be there. So then only we'll get the result. So it says like this, fat followed by rat within two positions. Then only we'll get the true result or we'll get the search results in case of TS query. Now let's see prefix matching. So the prefix matching is also possible if we don't know the complete word and we want to do search on a portion or part of a word. So in that case prefix matching is also helpful. So we can provide only super if we don't know the complete word. So on the basis of that also we can do the searching. Now let's see weights in tsquery. To tsvector we can assign weights to tsquery as well. So for example, here we have written the lexeme fat and then the weight is AB, and cat, for cat there is nothing, that is the default. So we can see the output. So here we can see the output fat is assigned the weights AB and cat is default. Now let's see how to normalize query using the toTS query. Similar to toTS vector, we can use the toTS query function also. So in this case, we have the English language selected. The toTS query function is there, and we have these lexemes like fat, AB, and cat. So let's execute to see the result. So here we can see that instead of cats, it takes as cat. So the search will be done on the basis of cat. Now let's say using @ operator to match TS vector with TS query. So for example, the data that we had inserted into the documents table, we'll use that one. So where we are comparing like this content vector we are searching, and @ to TS query we have taken and we are parsing it to English, where we are searching fat and rat is present. So that means the result will be populated if in the document if fat and rat both the words are present. So let's query and see if they are present or not. So here we can see in the first record we have this one, fat cat sat on mat and ate a fat rat. So here we can see that fat is also there and also rat is also there. And similarly in the second result also we can see fat is there and rat is there, and we know that we have parsed it to two TS query. So instead of cats it will search for cat. So this is how we can match the TS vector with TS query. Now let's see an example of prefix match. So in this case we are taking two TS vector postgraduate and then @ operator to match to TS query postgres. This is the prefix one. So let's see if it returns true or not. It should return true because we are doing the prefix matching. So yes, it returns true. So the conclusion is use tsvector to store normalized searchable content, use tsquery to write advanced search queries with Boolean and prefix operators, use toTSVector function and toTSQuery function to normalize text appropriately, combine both with @ operator to implement powerful full text search in PostgreSQL. So this was all about text search data type in PostgreSQL database. If the video was helpful, do like the video and subscribe the channel to get the notifications for upcoming videos. In the next video, we'll cover the topic of UUID data types in PostgreSQL. So let's meet in the next video. Till then, take care. Bye bye.